Hello people and welcome back to Maybe Ismail. In this session we will be studying equations of line. We'll start from the very basic, what is a line and whatever is required to form the equation of line, what are the types of equations of lines, and all those things we'll get to know in this one. So yeah, let's start from the first thing that we need to know about a line, and that is a slope. Now, what is a slope? Slope is basically also called as a gradient. Now, what's a gradient or what's a slope? Let us try to understand what slope is from the very beginning. Let's say I have this pencil with me over here. Okay, now this pencil, if I have it parallel to the floor which I am like maybe sitting on, so this pencil will not have any slope. Or if I just start tilting the pencil, it will start having some kind of a slope. Now I know it is very difficult to imagine in terms of a line, so let us not consider in terms of a line, let us consider in terms of a plane. So let's say I have this plane over here, this plane surface. Okay, now if I pour some water over here, I know that the water will not go anywhere, it will stay right here, it is gonna stay right here, it will not go anywhere. But as I tilt this plane, I know that the water is going to flow away from the higher level to the lower level, and the reason for that is this thing has a slope to it. Now similarly, if a plane can have a slope, a pencil or a line can also have a slope. Now whenever we talk about slope, we compare it with the floor or with the x-axis. We have two axes, the x-axis and the y-axis. We always compare slope in terms of the x-axis. Now this thing, if it is kept like this, it has no slope. And also I can say a slope is basically some angle that the line or a plane makes with the x-axis. No slope, no angle. But if I tilt it a little bit, now this thing has some angle. If you see over here, this angle, this is the inclination of this line, inclination with the x-axis, and it also has a slope. Now let us try to visually understand in terms of mathematics. So I have an x and a y-axis. Let me just quickly draw that. So that's my y-axis and this is my x-axis. Let's say I draw a line over here, this blue color line. I know that this line is going to have some kind of a slope. Now, why do I say that this blue line will have a slope? Because I see that the blue line is not parallel to the x-axis. Okay, being parallel to y-axis is something different. We'll talk about that later. But here right now we're talking about being parallel to the x-axis. Now the blue line is not parallel to the x-axis, so it surely has some slope. Now, what do I mean by slope? How do I define slope? Slope is basically defined as rise over run. So slope is rise over run. Rise, which means how much do I go up, and run, which means how much do I go ahead. Now it is basically comparing your motion in the x and the y axis both. Let us take a very basic example. Let's say you're walking on a street. If you just keep walking on a street, you will move ahead in one dimension, that is the x dimension only. The other example would be you are in an elevator. If you go in an elevator, you only move up or down. Again, you're traveling in only one dimension. But if you talk about staircase, you will be traveling in two dimension at the same time. Like if we climb up or climb down as walk down a staircase, we move ahead and up at the same time. Or if we are walking down, we move ahead and down at the same time. Similarly, a ramp in a parking lot, the car moves ahead and up at the same time. A flight, when it takes off or lands, it moves ahead and the vertical distance also changes. So anytime when something moves and its horizontal as well as vertical distance changes, we call it to be a gradient or a sloping thing. Okay, so slope is rise over run. Now in terms of this blue line, can I say that this point over here is A and the x coordinate of A is x1 and the y coordinate of A is y1. And also if I talk about the other point, let's call it B. So the x coordinate of B is x2 and the y coordinate of B is y2. Now, as I said, slope is nothing but rise over run, which means how much do I rise upon how much do I run, how much do I move ahead. Let's call this point C over here. Now let's see how much is this distance B to C. This distance would be y2 minus y1, and this distance A to C over here would be x2 minus x1. So it would be x2 minus x1. Now why do I say it is x2 minus x1 and y2 minus y1? For example, this x1 point is 2 and this x2 point is, let's say, 10. Then how much is the distance between x1 and x2? It is 8. How do you get the 8? It is 10 minus 2. So the farther number minus the closer number. So x2 minus x1. Similarly, y2 minus y1. That is how you figure out the distances between them. So if I talk about rise over run over here, so how much did I rise? I went up y2 minus y1. That is how much I went up. So it is y2 minus y1. And how much did I run? How much did I go ahead? So it is this distance, which is x2 minus x1. So if I give you 2 points and I ask you to find the slope of the line when I join the 2 points, it would be y2 minus y1 upon x2 minus x1. Now, if you think in terms of trigonometry, you must have surely seen a ratio in a triangle which talks about this side and this side at the same time. Oh yeah, if I call this thing as theta over here, that angle is theta, then the opposite over the adjacent, we know that opposite over adjacent is nothing but tan theta. So I can also say that the slope of anything is tan theta, where theta is the inclination with the x-axis. The thing I was talking about, inclination, this angle with the x-axis. Okay, so in order to find the slope of any line, you either need the inclination. So if I tell you that the inclination theta is 45 degree, 30 degree, or whatever degree, you can say, okay, so the slope would be tan of that angle. Or you need 2 points. If you have 2 points, you can use this formula y2 minus y1 upon x2 minus x1, and that would be the slope of the line. I hope that is very clear to everybody. Let us try to figure out the slope of a line whose points are given, let's say. Okay, so the question could be find the slope of a line passing through I know my handwriting is very good, so just pardon me for that. Passing through the points, let's say P, which is 2,5, and Q, which is, let's say, negative 7, 10. Okay, so now the 2 points are given to me. Let us try to fix those points, x1, y1, x2, y2. Can I just say that this is x1 and I can say that this is y1? And this over here would be x2 and this one would be y2. Now, some people might have a doubts. Do I have to consider the P point to be x1, y1 and the Q point to be x2, y2? No, nothing like that. Any 2 points, you just consider anyone to be anything, x1, y1 and x2, y2. It doesn't really matter. Okay. Now, I have the formula that the slope is y2 minus y1 upon x2 minus x1. Now, y2 minus y1. Now, also I would say that the slope is represented by m, small m, that represents the slope. y2 minus y1. What is y2? It is 10 over here, minus y1. What is y1? It is 5. So 10 minus 5 upon x2 minus x1. x2 is negative 7 minus x1 is 2. So negative 7 minus 2. So that thing would be 10 minus 5 is just a 5 upon negative 7, negative 2 is a negative 9. So finally, I can say that the slope of this line, which I am finding out the slope for, is negative 5 over 9. That is the slope of the line. That is how you find the slope of that line. Okay. Now, let's say if I have been given a question which says find the slope of a line having an inclination of 30 degree. So I would say that the slope, that is m. So if theta is given to me as 30 degree, my slope, that is m, would be tan theta, which is tan 30, which would be equal to 1 over root 3. Okay. Now, if you are someone who uses a calculator, you would be getting angles that would be anything other than the standard angles also. But if you are someone who does not use the calculator, if you are in such a board which do not permit calculators, then you would surely get the slopes to be 0, 30, 45, 60 and 90 only, nothing other than that. But if you are someone who uses a calculator, you would be given any angle and you should be able to find the slope of any line if any angle is given to you, because tan of that angle would be the slope of the line. Okay. Now, let us move ahead to a correlation between lines. Okay. So let's say I have 2 lines. I just draw 2 lines over here. This is my first line. That is my second line. I can say that these 2 lines are parallel to each other. I can say this is L1 and this one is L2. Now, if the 2 lines are parallel, any 2 lines, if they are parallel to each other, I can surely say that the slopes would be equal. So, let's say the slope of the first line is m1 and the slope of the second line is m2. From here, I can say that m1 will be equal to m2. So the concept is, when lines are parallel, the slopes are equal. When lines are parallel, the slopes are equal. Okay, m1 is equal to m2. Very important. Next concept. Let's say I have a line over here like this and I have another line over here like that. Okay. I could say that these two lines are perpendicular to each other. I can say that them are perpendicular to each other. This is L1 and let's say this is L2. I can say that the slope of L1 is M1 and I can say that the slope of L2 is M2. Now, when lines are parallel, the slopes are equal to each other. But when lines are perpendicular to each other, the product of the slopes is -1. So M1 times M2 is equal to -1. Now, I would not be explaining why this holds true because it needs a formula, that is a compound angle or allied angle formula. So you won't be able to figure it out right now. But you can just take this from me that when lines are parallel, it is very obvious that the slopes are equal. But when lines are perpendicular, that the product of the slopes is -1. It's not very obvious over here. But we can prove it very easily. That's like some 4 steps to prove it. Okay, so when lines are perpendicular, the product of their slopes is -1. This is a super important thing over here. Okay, let's say I tell you that the slope of L1 is 3/4, and I ask you what would the slope of L2 be. Super easy. You do not have to do the product and all those things. Super easy. Flip the fraction and change the sign. So 3/4 becomes 4/3 and I change the sign. Okay. Another example. Let's say that the slope of L1 is -5/7. So the slope of L2 that is perpendicular to it would be flip the fraction and change the sign. When I flip the fraction, it becomes 7/5. Since it was negative, it becomes positive. That is what it is. I don't need to give you an example for parallel lines because obviously you people are smart. Okay. So this is what the entire concept of slopes is. Now slopes could be positive, slopes could be negative, slope could be 0 if something is parallel to the x-axis, or the slopes could be infinite. Yes, exactly. Slopes could be infinite. If the thing is parallel to the x-axis, the slope is 0. But if the thing is parallel to the y-axis, the slope would be infinite. Why is it infinite? Because when something is parallel to the y-axis, let me just draw a rough diagram over here. When something is parallel to the y-axis, the angle with the x-axis would be 90°. And we know that tan 90 is basically not defined, or we also call it infinite. In some cases it is truly not infinite, it is not defined, but in terms of slope, if we talk, it is surely an infinite slope. Okay, so that is something to be kept in mind. Okay, now let us move ahead with equation of line. Okay, the thing is, equations of lines are basically of a lot of type, but the standard form of the equation of line is basically ax plus by plus c is equal to 0, and that is a basic fact which everybody should know. So what I'm talking about is that the equation of line should look like ax plus by plus c is equal to 0. That is exactly how the equation of line should look like. Now what is a, b and c? A, B and C, three things, all these three things are constants. Okay, it could be any number, positive, negative, fractions, decimal, whatever you feel like. These are any real numbers. Okay, what is x and y? X and y is basically the variable of the x and y axis. Okay, now I can keep my equation of line in this format, or I have another format which is y is equal to mx plus c. Now in your examination, you could be asked to keep the equation of line or to report the equation of line in either of these two formats. They could say that give the answer in the slope intercept form. So the slope intercept form is basically this one. I'll talk about the slope and the intercept and all those things later on, but let's just discuss about this. So the first thing that I've written over here is the standard form. This is the standard form and this is the slope intercept form. Okay, now I will talk about what intercept is, but right now these are the two forms which you should know. Okay, now can I convert anything from the standard form to the slope intercept form? Absolutely yes. How do I do it? I'll just show it to you here. So just keep the by over here, send the ax and the c to the other side, so it becomes negative ax minus c because side change, sign change. Divide everything by b, so y is equal to negative a over b x minus c over b. Okay, that is a very interesting thing. Now if I look at this thing over here, y is equal to mx plus c, look very carefully. I talked about the thing m is basically the slope. So if I have to compare these two equations, the y is equal to mx plus c equation and the other equation y is equal to negative a over b x minus c over b. If I compare these two equations, I can surely say that the slope of any line is negative a over b. That is a super important thing to note, that slope of any line from the standard equation, like if this equation is given to me, ax plus by plus c is equal to 0, the slope of this thing would be negative a over b. Let us take a basic example. Let's say I have an equation 2x plus 3y minus 5 is equal to 0. I need to find the slope of this line. How do I do it? I know that the formula is negative a over b. The slope of this line is negative a over b. So m would be equal to negative. What is a? A is the coefficient of x. So it would be 2 over b, which is 3. 3 is, b is basically the coefficient of y. So I just write 3 over here. So the slope of this line is negative 2 over 3. Okay. You could also come across questions which could say that there is a line which I need to find and the slope of that line is basically perpendicular to the other line which is given. So just figure out the slope of whatever line is given to you. If the required line is parallel, just use the same slope. But if the required line is perpendicular, just flip the fraction, flip the slope and change the sign of it. You'll get the slope of a perpendicular line. Okay. I hope that is clear. Let's just take one more example. Let's say I have an equation which looks like negative 5x minus 7y minus, or let's say plus 12 is equal to 0. Now I again know the same formula. It is negative a over b. So slope would be equal to negative a. A is negative 5, so I just write negative 5 over b. B is negative 7, so negative 7. This thing would be negative, negative is just a positive, 5 over negative 7, which is negative 5 over 7. So that's the slope of this line. I hope you would be comfortable with doing these basic things of figuring out the slope if the equation of line is given to you. If it is given in the slope-intercept form, you can just directly look at the coefficient of x and that is your slope. But if it is given in the standard form, this is how you do the slope. Okay. Now let us move ahead to the forms of the line, like what types of equations of line, like how do I make the equation of line. Okay, so let's start with a very basic thing. So let's say I have a point over here. This is the point that I'm holding. Okay, how many lines can I pass through this point right here? I can technically pass infinite number of lines. So there could be a line which could go like this. That's one of the line which passes through this point. There is another line, there is another line, there is another line. There could be infinite number of lines that could pass through this point. I have another point over here. Again, there could be infinite number of lines that could pass through this point also. But if I talk about these 2 points, if I have to pass a line like that should pass through these 2 points, how many lines could I have? I would have only one single line. So if I want to draw a line, we need at least 2 points, and when I connect these 2 points, I'll get a line. That is the fundamental idea. Like, I know when we were kids, we used to draw those things, connecting the dots and all those things. That's exactly what this is. I have one point, I have another point, I connect these 2 points, I get a simple straight line. That's what it is. So the way to find the equation of line is basically using the 2 points that are given to us. Okay, another concept. I have one point. Okay, how many lines can I pass through this? I can pass infinite number of lines through this point. Next, I have this line. How many lines could be parallel? How many lines could be parallel to this thing? So there could be infinite number of lines. So let's say this is a line which is parallel to it. This is another line that could be parallel to it. This is another line, that's another line. That I could have infinite number of lines that could be parallel to this white line. Okay, so how many lines can I have that would pass through this point and also be parallel to this line? So there could be only one line that would pass through this point and would also be parallel to that white line. So that is another concept. In order to make a line, or in order to form an equation of line, we need a point and a parallel line. And if you remember, if a parallel line is given to me, basically the slope is given to me. So I could either form the equation of line by slope and a point, or I could find the equation of line by a point and another point. So let's start with the first thing, which is the 2-point form. Okay, the 2-point form. Okay, what is the 2-point form? Let's say I have a line over here. That's my line. Okay, and I have a point which is A, and the coordinates of A are x1 comma y1. And I have another point over here that is B, and the coordinates of B are x2 comma y2. Now the 2-point form is very simple. It is y minus y1 upon y1 minus y2 is equal to x minus x1 upon x1 minus x2. That is basically the 2-point form. You just need to plug in the values of x1, y1, x2 and y2 in this equation. You'll straight up get the equation of line. Okay, let's do an example over here. Let's say I have to find the equation of line that passes through some point. So the question would be, find the equation of line passing through let's say I have a point A which is 2 comma 4 and I have a point B which is 3 comma negative 5. These are the 2 points. Okay, so I'll use this form which is the 2-point form. And why do I call it 2-point form? Because it is like 2 points that are given to me. Okay, so y minus y1. y1 is basically this thing. So y minus 4 upon y1 minus y2. So 4 minus y2 is negative 5. So it would be negative 5 is equal to x minus x1. x1 is this thing. So 2 upon x1 minus x2. So x1 is basically 2 minus x2 is this 3 over here. Let us try to simplify this. It would be y minus 4 upon 4 minus of minus 5, which is 4 plus 5, which is just 9, is equal to x minus 2 upon 2 minus 3 is negative 1. The negative 1 goes to the other side, the 9 goes to the other side, and it becomes negative 1 times y minus 4 is equal to 9 times x minus 2. Okay, now this negative 1 goes inside of the bracket and it becomes negative y plus 4 is equal to 9x minus 18. Send all of these things to the other side. So 9x remains where it is. The negative y goes to the other side. Side change, sign change, plus y minus 18 minus 4 is equal to 0. So that would become 9x plus y minus 22 is equal to 0, and that is the equation of line. Now I would recommend you people to either use Desmos. Desmos is a graphing app which is freely available on the internet, or you could also download the app and you just plot this thing on Desmos and check what it turns out to be. The more you visualize what you're doing, it would be more helpful for you. If the slope is positive, if the slope is negative, what happens when the slope is positive? How does the line look like? What happens when the slope is negative? Either use Desmos or you people can use this kind of a graphing calculator. I use this calculator. So if you use this kind of a calculator, you'd be able to also visualize it. So it would be a really helpful thing for you if you are new to all of these things and you don't know what it is. So yeah, that would be really helpful. So this is how we find the equation of line when 2 points are given to us. Let us move ahead to another form, which is the slope point form. It is the slope point form. Now, what is a slope point form? Basically, let's say I have a line which is given to me and I have a point on that line. Let's say this is a point P and the coordinates of P is x1 comma y1. Now, let's say I have also been given the slope of the line. If the slope of the line is given to me, let's say it is m. I don't know what it is, but it is m. Okay, and I need to find the slope of this line. So it will be slope point form. Why do I call it slope point form? Because the slope is given and the point is also given to me. So it would be y minus y1 is equal to m times x minus x1. That is the slope point form. Okay, let us pick up an example. Let's say we need to find an equation. I won't write the entire statement. Let's say there's a point P which is given to me. Point could be anything. Let's consider negative 2 comma 7, and let's say the slope is given to me as 3 over 4. Okay, now how do I do it? Very, very, very easy. I know what x1 and y1 is. This negative 2 is x1 and this 7 over here is y1. So it would be y minus y1. So y minus 7 is equal to m. M is 3 over 4. So 3 over 4 times x minus x1. x1 is negative 2. I'm deliberately taking negative value so that I just make sure that you understand that if there is a negative in the formula, you also have to consider the negative of the point that is given to you. Okay, so this 4 can go to the other side. So it becomes 4 times y minus 7 is equal to 3 times x minus of minus is a plus 2. When I open up the bracket, it is 4y minus 28 is equal to 3x plus 6. I just send all of these things to the other side. So it becomes 3x. The 4y goes to the other side, becomes negative 4y plus 6 and plus 28 is equal to 0. So that becomes 3x minus 4y, and this should be plus 34 is equal to 0. Okay, that is the equation of line. Now if you observe in both the questions that we've done till now, like both the examples that we've done, I have kept my answer in the standard form. Ax plus by plus c is equal to 0. So the form is always a standard form. If it is not mentioned in the question, I prefer keeping it in this form. Even in the previous question, if you see, it is ax plus by plus c is equal to 0. I always prefer keeping it in this form. You can also keep it in the slope-intercept form. Okay, we'll talk about intercept later. Yeah, that's a thing. Okay, let us move ahead to the next thing. The slope-intercept form. Okay, the slope-intercept form, very interesting. Slope-intercept form. Now, before doing slope-intercept form, we should know what an intercept is. Now, intercept is just a fancy word for intersect. Okay, it just means intersect. Okay, so if I have the x and the y axis over here, and I have a line which intersects the y axis at any point c, okay, or this distance over here is c, or it intersects at that point, at that particular point c, then that is my y intercept. Okay, so when I talk about the slope intercept form, I'm basically talking about the slope of the line, and I'm talking about the y intercept of the line. So let's say the intercept is c and the slope of this line is just m. So what's the slope intercept form? Very easy. It is y is equal to mx plus c. Simple. C is basically the y intercept. C is the y intercept, or a point where it intersects the y-axis. Okay, let's pick up a question. Let's say I have a question which says I need to find the equation of line whose slope is negative 5 over 3 and its y-intercept is let's say 2. Okay, so now how do I do it? I just say it is y is equal to mx plus c. So it would be y is equal to m, which is negative 5 over 3 x plus c, which is the y-intercept, which in this case is just 2. Now obviously I won't keep it in this form. I'll want to keep it in the standard form. I have two ways. I either do the LCM stuff, or I just multiply the entire thing by 3. I prefer doing it this way. So 3 times y is 3y is equal to the term, the negative 5 over 3x, just get rid of the 3, so it becomes negative 5x plus 2 times 3 is just a 6. I would send all of these things to the left hand side. So finally my answer would become 5x plus 3y minus 6 is equal to 0. Now you all should have a question that in the previous two questions I moved things to the right hand side, and in this question I moved things to the left hand side. Is there some trick over here, or am I just being partial or something? No, it's not like that. I prefer keeping all the equations of line in this format, and I prefer keeping the coefficient of x always positive. Like I prefer the coefficient of x, like the value of a, to be positive every single time. See, in this question a is positive. Even in the previous one, a over here is positive. The 9th thing over here is positive. So that is the reason I just manage it according to whatever is required. Okay, so this is the slope intercept form to find the equation of line, if the slope is given and if the intercept is given to you. Now let us move ahead to the last method of finding the equation of line, which is the double intercept form. It is the double intercept form. Now the name itself suggests that double intercept means two intercepts, so we'll have two intercepts over here. Let me draw my x and y axis. So that is my x and y axis, and let's say my line intersects the x and y axis both like this. Okay, so over here this distance that I can see is the x intercept, and I call it as a. A is my x intercept, and this distance right here is my y intercept, and I call this distance as b. Okay, basically I'm talking about these points, that point and this point over here. So the point on the x axis would be a, and the point on the y axis would be b. Okay, so if two intercepts are given to me, the equation of line would be very easy. X upon a plus y upon b is equal to 1. I don't know if anybody has some kind of OCD or anything. I just now realized that this line over here is a little bit shorter than all of these lines. Okay, and that's now bothering me, and I'll be fixing that in the next video. Okay, fine, let us move ahead with this thing. Let's say I have been given a question which says that the x-intercept is 2 and the y-intercept is 5. Okay, so if the x and the y-intercept is given to me, it's very easy, extremely easy. Just write x upon a. A is the x-intercept, which means x upon 2, plus y upon b. Y upon b. B is the y-intercept. Y-intercept over here is just 5. So y upon 5 is equal to 1. That's it. Now, obviously, I won't be keeping it in this form. I have to multiply all of this thing by 10. If you understand that, that's a very good thing. If not, just take an LCM and do it. Okay. When I multiply the first one by 10, I get 5x plus the second one, I get 2y is equal to 10. I can bring this 10 to the other side. So 5x plus 2y minus 10 is equal to 0. And that is my equation of line. I'll try taking another example over here. Let's say my x-intercept is negative 3 and my y-intercept is, let's say, 7. Okay, same thing, x upon a. A is negative 3 in this question, so x upon a plus y upon b. Y upon b, which means y upon 7 is equal to 1. This time I'll do the cross multiplication thing. So 7 times x, this gets over here. 7 times x is 7x. Negative 3 times y is negative 3y upon negative 3 times 7 is negative 21 is equal to 1. Send the negative 21 to the other side. So 7x minus 3y is equal to negative 21, and I would also send the negative 21 to the other side so that it becomes positive, and I'll just not do it. Okay. Now the thing is, you don't have to know the double intercept form. Like, even if the intercepts are given to you, let's try to bypass this formula. Let's say you don't know the formula, or you don't like using the formula, the double intercept form. How do you do it? Okay, let's see. I have the two intercepts that are given to me. Let's say on the x-axis, I don't think this line is straight. One moment. Okay, on the x-axis, let's say this thing is 8 and this thing on the y-axis is, let's say, 5. Okay, and I don't really feel like using the double intercept form, although I can use it, but I don't feel like doing it. Okay, so what do? I can say that I know the fact that any point on the x-axis would have the y coordinate as 0. So this thing over here, the x-intercept, is not 8. It is basically 8 comma 0. It is 8 comma 0. That's the x-intercept. And what about the y-intercept? This is not 5. This thing is actually 0 comma 5. Okay, so now if I see that the x-intercept which was given to me is a point and the y-intercept which was given to me is also a point. Okay, because anything on the y-axis will have the x coordinate as 0, anything on the x-axis will have the y coordinate as 0. Oh, which means if two intercepts are given to me, that concludes that 2 points are given to me, and if 2 points are given to me, I can basically use the 2-point form. Okay, what's the 2-point form? It is y minus y1 upon y1 minus y2 is equal to x minus x1 upon x1 minus x2. Okay, so I'll consider this thing to be my first point. So x1 is 0. I'll just point it out over here, x1, and this is my y1. 8 is my x2 and 0 is my y2. Okay, let's do this. So y minus y1, y1 is 5 upon y1 minus y2. So 5 minus y2 is 0 is equal to x minus x1, x1 is 0 upon x1, which is 0, minus x2, which is just 8. So this becomes y minus 5 upon 5 minus 0 is just a 5 is equal to x minus 0 is x, and 0 minus 8 is a negative 8. Send this negative 8 to the other side, send the 5 to the other side. So it becomes negative 8 times y minus 5 is equal to 5 times x. Opening up the bracket, negative 8y plus 40 is equal to 5x. I send all of these things to the right hand side. So 5x plus 8y minus 40 is equal to 0, and that is the equation of line. Now let us try doing the same thing with the help of the double intercept form. So it would be x upon a, which is 8, plus y upon b, which is just 5, is equal to 1. 5 into x is 5x, 8 into y is 8y. The whole thing upon 8 times 5 is just a 40 is equal to 1. Now send the 40 to the other side. So 5x plus 8y is equal to 40, and 40 comes to the other side. So 5x plus 8y minus 40 is equal to 0, and there it is. I got the same exact equation. Okay, one more thing. If I go back to the slope-intercept form, I mean the slope point form, and I see that this formula is y minus y1 is equal to m times x minus x1, and the 2-point form is y minus y1 upon y1 minus y2 is equal to x minus x1 upon x1 minus x2. Okay. What if I tell you that these two formulas are exactly the same formulas? Okay. Let me just prove it to you very quickly. Okay. And obviously you won't be needing it, but if you just know it, that would be so good. So y minus y1 upon y1 minus y2 is equal to x minus x1 upon x1 minus x2. This is the 2-point form because 2 points are given to me. What I do is I just send the denominator of the left hand side to the numerator on the right hand side. So it becomes y minus y1 is equal to this y1 minus y2 goes there. Okay, and I just write the x1 minus x2 right below this. So x1 minus x2, and the x minus x1 just stays there, it hasn't gone anywhere. Now if you remember from the first concept that we studied in this class was slope, and by definition I said that slope is rise over run, which is y2 minus y1 upon x2 minus x1. If I just flip these things or I factor out a negative sign, I realize that this thing over here itself is the slope. So that is exactly what y minus y1 is equal to m times x minus x1 is. This is the slope point form. So basically we can derive the slope point form from the 2-point form and use it. So if 2 points are given to me, you don't have to use the 2-point form, you can use the slope point form also. Just figure out the slope from the 2 points and then use either of the points. So if 2 points are given to me and I've also figured out the slope, I don't have to use point A or point B, like I don't have to think about it. I can use either of the points, I'll get the same exact equation. And that is the entire concept of this thing. Now, one last thing is that if the equation of line is given to you, let's say I've been given ax plus by plus c is equal to 0. If this equation is given to me and the question says find the x-intercept or find the y-intercept, or find the point at which the line intersects the x-axis or the point where the line intersects the y-axis. Super easy. For x-intercept, you have to substitute y is equal to 0. Simple. And for y-intercept, you have to substitute x is equal to 0 in this above equation, ax plus by plus c. No matter what way the equation is written to you, just plug in the value of x as 0 if you want the y-intercept and plug in the value of y as 0 if you want the x-intercept. Let us take a simple example. Let's say I have 2x plus 3y plus maybe 6 is equal to 0. If I want the x-intercept, I'll just substitute y as 0. So it becomes 2x plus 3 times 0 plus 6 is equal to 0. So 3 times 0 is just 0. So this thing becomes 2x plus 6 is equal to 0, which means x would be equal to negative 6 over 2, which is negative 3. So that thing is my x-intercept. This negative 3 is my x-intercept. And in order to find the y-intercept, I would just plug in the value of x as 0. So this becomes 2 times 0 plus 3y plus 6 is equal to 0. 2 times 0 is just a 0. So 3y plus 6 is equal to 0, and y would be negative 6 over 3, which is negative 2, and this negative 2 is my y-intercept. And that would be it for this session. In the next part of this thing, we will be solving a lot of questions, not specifically from any textbook, but we will be doing almost all kind of questions that turn up, and we'll focus only on questions, and we will also probably go through a few concepts that are not part of this chapter, but you would probably need to know to solve these questions. And I would just name it. It is the midpoint formula and the section formula specifically. If you know these two formulas, you will be able to do almost every question of this chapter. And that is it. Thank you so much. Subscribe please and like. Thank you so much. Bye.